equation 5 from your handout. Hit pause, record the equation onto your paper, and now I want you to try this one all on your own. Come back and watch the problem worked out. Okay, please check your understanding. Assign oxidation numbers. Iron is a +2 here. That oxygen's a -2, so this manganese has to be a +7. This manganese is a +2, and this iron is a +3. Step 2, identify what's oxidized. Again, we're looking for the increase in oxidation number. That's going to be your iron. It went from a +2 up to a +3, number increase. That means oxidation. There is 1 iron in this equation. It's changing by 1 oxidation number, and so that's 1 electron. It gives me 1 electron lost. Let's go for the reduction. The manganese is being reduced. It's going from a +7 down to a +3 because it's gaining electrons. That tells me this is reduction. There's 1 manganese atom, and its oxidation state is changing by 5, indicating 5 electrons are being gained. Oops, sorry. Next step, double check your electrons. They have to balance. Right now, no bueno. They're not good. They're not balanced. You're going to have to multiply the iron oxidation half by 5 because we know the total number of electrons has to be conserved. So we're going to multiply this by 5. And so all the irons get multiplied by 5. We end up going coefficients of 5 in front. Next step is to balance your oxygens. We have 4 oxygens on the left, no oxygens on the right. That means I'm going to have to add in 4 waters on the right side. Next step, balance your hydrogens. I now have 8 hydrogens on the right. I now need 8 hydrogens here on the left. Finally, clean it up a bit. That way, it's a little bit easier to double check your final answer. You're going to have your hydrogens and your iron 2+ and your permanganate, your reactants, and you're producing manganese ion, iron 3+, and 4 waters. Double check if you're balanced for atoms. Double check to make sure you're balanced for charge. And just for good practice for that charge, we have +8 from the hydrogens, 5 times 2 is +10 from the irons, and then a -1. Remember, you're just taking the coefficient and you're multiplying it by the charge of the compound. I get a total of 8 plus 10 is 18 minus 1. I get a total +17 on the left. Over here on the right, the manganese is a +2. I have +15 from the irons and then 0 from the water. 2 plus 15, 17. Check, check. Yes, this is my final balanced net ionic equation for this redox reaction. All right, let's try equation 6. Again, hit pause, record the original equation on your paper. You try first, balancing on your own, then come back and check for your understanding. All right, step number 1, always assign oxidation states. So oxygen, okay, -2. This nitrogen, I know that it needs to add together with these 3 oxygens, which gives me a -6. They had to add up to -1 because that's the charge of the nitrate ion. So the nitrogen has to be a +5. The sulfur by himself, no charge, 0. Over here, oxygen is -2. The nitrogen has to be a +4. And then here, okay, hydrogen is going to be a +1. Oxygen is a -2. So now I have to solve for sulfur. If each hydrogen has an oxidation of 1, but you're using 2 of them, you really have to do 2 times +1 plus the sulfur plus the 4 oxygens, which each carry an oxidation state of -2. And all of that added together, I look at the charge of the compound, it's 0. So I'm going to need to solve for the sulfur. So 2 plus sulfur minus 8 is equal to 0. So our sulfur is going to have to equal a plus 6. Next step, identify what is oxidized, meaning whose number increased. I'm looking, okay, sulfur, here it is. Sulfur started as a 0, it ends as a plus 6. That is an increase in the oxidation number. So that means we have oxidation for the sulfur. There is one sulfur atom, and it's changing by 6 electrons. And so that gives me 6 electrons lost. Now we're going to take a look at our reduction. I notice here that the nitrogen has decreased in oxidation number. So that is my reduction. There's one nitrogen in the equation. It's changing by 1 electron. So there's 1 electron gained by this reduction half reaction. I know electrons have to be the same number. Right now, they're not. So I'm going to need to multiply the reduction equation by 6. So I get 6 electrons for reduction to match the 6 electrons in the oxidation half. And so that means I need to multiply the coefficients of wherever the nitrogen is located by 6. Now I balance for oxygens. And if I just quickly add up the number of oxygens on the left, I have 18 oxygens on the left. And I have 6 times 2, that gives me 12, plus 4. So that is 16, 12 plus 4, 16 oxygens on the right. And so I need 2 more oxygens on the right, so I need to add 2 waters to the right side. Finally, you're going to balance for the hydrogens. And real quickly, let's calculate how many hydrogens we have. I have 2 hydrogens in the H2SO4 plus 4 more. I have 6 hydrogens on the product side. So I need to add 6 hydrogen ions to the reactant side. Finally, let's clean this up. I have 6 hydrogen ions, 6 NO3 ions, sulfur, that's a solid, 6 NO2 gas, 1 H2SO4 aqueous, and 2 H2O liquids. Finally, check to make sure that you are balanced for atoms, you're balanced for charge. I'm just going to double check my oxygens. Just want to make sure. I have 6 times 3, that's 18 there. 6 times 2, that's 12. 12 plus another 4 is 16, plus another 2, that gives me 18. Okay, check, we're good. And then hydrogen should work out 2, and then 4. Okay, 6. Cool. So now double check your charges. I have a plus 6 from the hydrogens, 6 times -1, that's a -6, and 0 from the sulfur. I have a total of 0 charge on the reactant side. Over here on the product side, 0 charge on the NO2, 0 charge on the H2SO4, and 0 charge on the waters. They all add up to 0, 0, 0, check, check. We have our final balance net ionic equation for this redox reaction.